Here's a few example problems on transformation of trig functions. So remember, you're fundamentally starting with the graph of sine x, which has an amplitude of 1, starts 0, goes up to 1, down, has a period of 2 pi, right? And that continues indefinitely in both directions. And then cosine also has an amplitude of 1, but it starts at 1, goes down, its period is also 2 pi, and still continues both directions, right? So what we're going to be looking at is what different stretches and shifts do. So this, I'm keying in on the amplitude number here. If there's nothing there, then it's implicitly multiplied by 1. That means there's an amplitude of 1. What would the range be? Well, this means the max and the min of the graph are 1. So -1, +1. So the range, the output possibilities is -1 to 1. The period is affected by this. Now, interestingly enough, the negative sign doesn't affect the period. By default, the period of both is 2 pi. But you might remember we have this formula, period equals 2 pi over b, where b is that number there. So let me show you what that is. This says that the period is 2 pi thirds, but then sort of let me show you what happens there as I sketch this, okay? Let me think about what would happen if you had a period of 2 pi. Well, x is going to start at 0. It's going to end at 2 pi thirds. So what would halfway in between there be? Let's see, is that enough lines? I think I might need to lower my 2 pi thirds just a little bit. 2 pi thirds. Okay, well, half there is pi thirds, right? That should be sort of halfway through the period. And half of that is pi sixths. And let's see, 1 pi 6, 2 pi 6, 3 pi 6 is pi halves, okay? And so this period, if I'm going to plot it all the way out here, there's 2 pi thirds, there's pi thirds, right there, the sixths. I'm going to do 2 periods, one in the positive direction, one in the negative direction, -2 pi thirds, -pi thirds. And I won't maybe belabor the other ones so much, but what happens if you plug in 0 here? Well, you're going to get cosine of 0. That's 1. What happens if you plug in pi sixths? Can you see you get cosine of -3 pi sixths? That's cosine of -pi halves. Well, what's cosine of -pi halves? Same as cosine of pi halves. That means we're down here. That's 0. So we're 0, 1, pi 6, 0. Then where are we going to be? You can check this yourself. We go down to -1, up to 0, up to 1. That's 1 period. There's another period. What happens if I have something like this that has shifts? I intentionally chose something that's a little tricky there, okay? Well, you could look at this as cosine of -x plus 2, or I prefer to look at it actually as negative the quantity x minus 2. These are shifts, okay? So what's the amplitude do? Well, the amplitude is just 1. The range is changed by a +1 at the end, okay? So this graph is going to go from 0 to 2. Why? Well, the middle is shifted up by 1, and so you can imagine that a cosine curve, if it's shifted up by 1, would go 0 to 2. So I'm going to put the range here. Okay, what about the period? Well, the period actually is not going to be affected, right? There's just 2 pi here, and you can plug in specific points. If you're ever in doubt, you can see that I can plug in points along the way to get this. Now, what this negative inside a cosine doesn't do anything because the left side and the right side of the cosine does the same thing. But what does the minus 2 do? That's a big deal, okay? Well, so what has to happen so that it thinks this is cosine of 0? You actually have to be at the point 2, okay? So cosine of 0 is 1, and we're going to add another 1. Then how far does it go from there to get to the bottom of the trough? Well, that's actually cosine of pi, right? That's halfway around. So what do I have to put in there? I actually have to put in 2 plus pi. 2 plus pi, right? That would get me to the bottom. And then 2 plus 2 pi. Now, technically, this is what? If pi is 3.1, this is 5.1. If 2 pi is 6.2, this is 8.2. But let's just write it in its components because this is actually shifted right. So that's 1 period. We can go the other way. 2 minus pi is down there. 2 minus 2 pi is all the way down there. So that's something like what it looks like. Don't forget you can use Desmos to sort of check this and check your intuition and such. Now, I think that when you have a horizontal stretch and a horizontal shift, this can be particularly sneaky. What I always try to do is I try to factor out the horizontal stretch. So the 2 goes there, x minus pi halves. Can you see that if you have a factor there, that 2 would distribute, and I'd get the same thing there. But what this is an amplitude of 2. The horizontal stretch is associated with that. Don't forget, because the amplitude is 2, that just means the range is going to be -2 to 2. The period is going to be what? 2 pi divided by 2, which is pi, okay? That means everything's going to happen in intervals of pi, but this is actually the shift, okay? So whereas in the last problem it was shifted right by 2, now it's shifted right by pi halves, okay? So pi halves is where the sine curve is going to start. The sine curve goes up and down, and then 1 full period is going to end at pi farther. That's 3 pi halves. Halfway in between those is pi. So I'm going to go all the way up and all the way down, all the way down and all the way up. And you can actually go through and check this. Check that, for instance, at 3 pi fourths. If you plugged 3 pi fourths in, first thing you do is multiply by 2. You'd get 3 pi halves, right? 3 pi halves minus pi is pi halves. Oh, look, that's exactly what sine of pi halves looks like. It's the max there. Now we can go backwards. That my scale is a little off here. If I subtract pi halves, I go back to there, and then another pi halves. I go to there, that's 2 periods.